Well, hi everyone. Here we are for part 12 with Dr. Nathaniel Jeanson on rewriting history. Now, this particular episode, the resettling of the Americas before Columbus, what happened in the Americas before Columbus? What is the history of Native Americans? This is going to be very, very interesting. So, Dr. Nathaniel Jeanson, continue on with part 12.
I want to say at the outset that there's multiple things we're going to accomplish in this episode. There's going to be some radically new history we're going to learn. Because the history is so explosive, I want to defend it at the outset and derive it going from the present backwards. And in doing so, we're going to see one of the strongest evidences for the young Earth timescale that exists. We're going to look at the Y chromosome family tree. What I'm going to show you, we're going to start by saying, does the Y chromosome family tree reflect what we know about what happened after Columbus? Last episode, we talked about the fact that there was a massive population die-off. We're going to discuss how genetics can actually give you the smoking gun of this, and how it's only the young Earth timescale that sees this. So we're going to start with what everyone knows. Evolutionists say, yes, there was a massive population die-off. I'm going to say it's only the young Earthers that can see this. That's one of the first steps. And so that's what also should help convince people what the shocking things I'm going to tell them about what happened before Columbus are therefore true. That's our control. It has an apologetic purpose. It has a historical purpose. We're going to see that what we know from archaeology, what we know from these records, what even mainstream people are saying, yes, this is what happened. I'm going to say, and it's only our genetics that reflect this. Evolutionists don't see this. They can't see this. This is a strong confirmation of the biblical time scale. And it also gives us brand new insights into what happened before Columbus. So that's all we're going to try to accomplish in the next 30 minutes. Part of this larger question of who do we come from? Who are the people that are our ancestors, given all of our differences culturally, linguistically, physically that we see today? And how do we relate to these people in the ancient past? We're going to get a little bit closer to this question as it relates to the earliest people in the Americas, and we're going to do that today. So who are the Native Americans? Mainstream scientists would say their history, their ancestry is ancient. Going back in mainstream timescales to the last ice age, the Native Americans came across from Asia due to the land bridge that formed, came perhaps down the Pacific coast, perhaps on the ice-free corridor, and based on the earliest archaeological science we can find, this happened 15,000 years ago. You might have heard the term Folsom or Clovis. This refers to the specific types of points that they can find. This is a Clovis point. And based on other carbon-14 and other and radiometrically dated sites across the Americas, they say they came across and boom, dispersed across the Americas in short order. We'll talk about the limitations of carbon-14 dating for these ancient dates in future episodes. What we're going to do today is independently test this with genetics, because genetics has a clock within our cells. We'll talk about this more in a minute. So the mainstream timescale says they came across 15,000 years ago, where this isolated culture that didn't interact with anyone for over 10,000 years until Europeans arrived in 1492. There was some interaction with Leif Erikson, maybe around 1,000. That wasn't permanent. The first permanent narrative starts 1492, then with the Pilgrims and so on. So there's this meeting of very ancient cultures that hadn't encountered one another for 10,000 years. That's what the mainstream scientist says. And because the Europeans had developed bigger technology, they overcame their poorly armed opponents. We saw, of course, that part of the narrative was wrong based on mainstream science itself in our previous episode. There were massive numbers of people here who underwent a dramatic population collapse, so that when the US Army pushes westward, they're encountering a relic of the people who were once here. And so the seeds of this outcome were sown centuries prior. We've seen that these people were not primitive. We go through the rainforest today, cloud forest, oh, this must have been the way it always was. Not true. We can dig down below the surface. Mainstream archaeology says, no, these are not primitive peoples. These are survivors of a recently shattered culture, to quote Charles Mann's book, 1491. We've seen it, research that's ongoing even since then. Looking at a cloud forest in Ecuador, you look at the plant materials in one of the lakes that they looked at, you can see evidence for plants that are consistent with the cloud forest, but you dig down further, in the 1600s, it's grassland, and around the time of the Columbus, it's a farmland. This was not a cloud forest or rainforest. These people had transformed their environment around the time of Columbus, and this has all changed within a few centuries. It's not the way it appears. These were not leftovers from the Stone Age survivors of a recently shattered culture. So if this much of mainstream science and stereotypical views can change that fast due to archaeology within the last few decades, could this narrative and this aspect of the narrative fall as well? Is it really something that happened 15,000 years ago? Are they all the descendants? Are today's Native Americans all the descendants of the first Americans? Time and genetics would tell a different story than what we've been taught from mainstream sources for years. And because of what I'm going to tell you again is so explosive, it's worth, especially at this juncture, to review what we've covered in previous episodes, because these lessons apply and live in color to this question of who are the Native Americans. The world is smaller than we think. The world population has grown dramatically. This has dramatic consequences. We saw in episode 1 for how closely related we are. Same song, second verse in episode 2, looking at the math of how many ancestors we have. This must mean people are much more connected than we think they are. This implies that ethnic change can happen much more quickly than we think. We've looked at basic genetics in episode 3 to say, yes, this is very easy. And if you combine that with how fast or slow people can reproduce, if you combine that with the fact that slight differences in reproductive rates, this family has 2 kids, this family has 3. Apply that over multiple generations, and one group can overtake the other, yet look like the second group. We've seen that the majority of Europeans, Western and Eastern Europeans, are the descendants of Central Asians, even though they don't look like Central Asians. Episode 4 is key to understanding how that possibly can occur. And the key to all of this is the recognition based on the clocks within ourselves, and especially those clocks that mark off male inheritance. We've seen that our family tree is much shallower, much shorter than we think. It's only 200 generational steps from Noah, 8 people, to the nearly 8 billion people today. This is going to force our family trees to come together quickly. And episodes 5 and 6 went through the technical reasons why it's the male inherited DNA that's the key. And while the female inherited DNA, the mitochondrial DNA, marks off 6,000 years, there's statistical noise. We just can't be that precise with it to get into the details of history. Starting with Europe, on this tree, we've seen the lost relatives of Europe. Some of them are in India, some of them in Central Asia. There's many people who are of Mongol descent and don't know it. We've seen there's an ancient Chinese connection to Eastern Europe. We've looked at the question of who settled the Americas after Columbus. There's a hidden history of the vast majority of European descent Americans. Even Latin Americans have strong European descent. I say European, but the ancestors of most Americans and of Western Europeans are not who we think they are. They are Central Asians. So see those earlier episodes for that, for the justification for that. But I want our viewers to see that this revolution, this rewriting of how we think about who we are, and we're going to see this in a dramatic way today for the Native Americans, is just part of a consistent pattern we're seeing around the globe. This isn't something unique to the Americas. We've seen this in living color for Europeans. We've begun to scratch the surface literally in the previous episode, looking at archaeological discoveries in mainstream science that rewrite our understanding. Today, we want to look at the resettling of the Americas before Columbus. Now, we typically think of resettling as after Columbus. It's the Europeans who came in and resettled after wiping out the Native Americans, what once was Native American land. Well, who are these people? Who do they come from? Apart from written records tracing back genealogies for hundreds of generations, 100 or more generations, the only way you can answer this is with DNA. Now, in previous episodes, we mentioned that there was this mainstream scientific study of multiple populations, 26 populations around the globe. This is the 1,000 Genomes Project. They look at 26 people groups, multiple people within each group, 50 or so men from each of these groups, and looked at their DNA. And even though this doesn't cover a lot of the map here, we looked at the fact that this covers a lot of the places of where the people are. These are population dense centers of the globe. So it's a good first pass look at what our DNA looks like globally. And within this study, there were 4 groups here in the Americas of Native American ancestry. These are the 2 red ones were African Americans in Oklahoma and people of African descent in Barbados, and obviously of African descent in their DNA. If you want to know the Native American history, you need to look at these groups right here. So there were Mexicans in Los Angeles, Puerto Ricans in Puerto Rico, Colombians in Medellin, Colombia, and Peruvians from Lima. There's been 3 major studies of Native American Y chromosome DNA that I want to highlight. This is the first one. There was a second study we looked at that if the first study was taking a narrow slice of the global pie, but trying to look deeply at their history. This takes a much wider slice of the global pie, but looks more shallow. Many more people groups represented, but only a few men, a handful of men from each. And in this particular study, only a handful of Native Americans. These were about 3 groups of people from northwestern Argentina. There was a third study focusing exclusively or almost exclusively on indigenous Americans. And you can see there's a whole bunch of people's study with a heavy emphasis in Latin America. And Latin America, of course, if you remember from previous episode, is where in terms of pre-Columbian times, where the people were most concentrated. Only about 4 million people in the Americas, North America, north of the Rio Grande, upon the arrival of Columbus, 26 million in Central in Central America and the Caribbean, and about 24 million, and these are rough estimates, highly debated, in South America. Well, I want to focus on this particular study. All 3 of these studies give results that are consistent with each other. This particular study, even though it sampled a little bit of South America, it has the highest quality data. And it's a tree we've looked at before. Again, this is a family tree where time moves from left to right, not from top to bottom. The Native American section of this tree is found up here in light gray. To zoom in, this is what the people look like. I've mentioned in previous episodes, scientists assign letters and numbers to give you sort of a shorthand to know where you are in the tree. The major divisions that branch off from the beginning are assigned letters. And if those major branches get subdivided, you give a number to each of those subdivisions, and then a letter, a number, and letter numbers. You keep going through the tree. Well, this particular major branch is assigned the letter Q. To zoom in here just to see who's on this tree, you notice I've shown you not just in gray the Native Americans. They have a close genealogical relationship in pink here with Siberian peoples. You may not recognize these names, Selkups and Kets. Eskimos you might recognize. They're Siberians on the Asian side. They're classified in this study as that way. You can see in light green here, there's Uzbeks, Central Asians. And moving on down, there's these terms, these names for these groups may not be recognizable, but they're Andean by the Andes Mountains. These are the people who are present in this particular study. Now, I included these Siberian groups because it's been a long-standing dogma in the mainstream community that Native Americans came from a Central Asian group or Siberian group, but that it happened 15,000 years ago. And this time scale is so entrenched, it's used literally as a sanity check. Sanity check is the phrase used in the 1,000 Genomes paper. They looked at, when they studied the Y chromosomes, they created their whole tree, and then they said, okay, let's look at the Native American branches. If the timing of our tree lines up so that the Native American branches branch off from Central Asia 15,000 years ago, we've done it right. Then we know we're on the right track. That's how entrenched this time scale is in the mainstream community. I want to revisit this using a different sort of analysis. It's something we had discussed, I think, previously. I'm going to take it a step further, explain it slowly so we can all follow. So this is DNA from living people. What can we learn about the history before Columbus using DNA from the survivors? It's a little bit of a non-intuitive way to approach this. Well, the first thing that we can do is reconstruct the family tree. That's what this diagram is. It's branches, just like we might reconstruct if we had written records and say, okay, this is my dad up here and my mom, and this was their dad and their mom. We've rotated about 90 degrees so that the time moves from left to right. But this branching pattern is essentially a record of who comes from whom. It's just using the number of differences between various people. So these 2 men, every branch is 1 man. These 2 men have a short branch connecting them. They have few DNA differences. This branch is long. You have to go all the way down here and over and up here to connect these 2 men over to this guy. They have a much more distant common ancestor. And so the length of these branches represent family tree. They're essentially time scales. So as you move from right to left, you go backwards in time. And if you go from this direction, you're moving forwards in time. It's a family tree. So that's step 1. The second step in inferring something from these living people is to recognize that the branches of a family tree reflect population size. It's self-evident if you think about it. So if you were to look at my family tree, get the Y chromosomes from my 3 boys and my Y chromosomes, you can see 3 branches that come off from me. There's 3 males at the next generation in my family tree. Duh, of course, it's a kindergarten point. Well, that's true around the globe. If you reconstruct the family tree from people around the globe, the number of branches at various points in time is going to reflect the population size. So back here, you've got a whole bunch of branches coming off. Population must be growing. then it's flat, so there must not have been much population growth in this guy's family history. Then there's more growing up here. There must have been an increase in population size there. That's the principle behind this, and it's the principle we can apply globally and then specifically to this particular group of people. Now let me run through a couple of scenarios just so we can all follow how this works. Let's think of a theoretical family tree where it starts with some male ancestor in the past. And let's say we're watching this, we have supernatural abilities, we can time travel and can watch this family tree grow through time. He has 2 boys, so then he's got 2 more branches on his family tree. And we're time traveling, and we're watching these boys grow up, get married, and they each have 2 boys as well. Same thing happens in the next generation as we travel through time. They have 2 boys, and on this goes over time. If we were to take the DNA from those living people, let's say those people are now living today, we'd get their DNA differences, we can reconstruct this family tree here. We could go through time and count the number of branches to reconstruct that population history that we just, in theory, watched through time travel. So if we're now in the present, we've lots of supernatural abilities. All we've got now is the 2, 4, 6, 8, 16 men alive today. And we can reconstruct their family tree from DNA. It looks like this. All we have to do is go walk back through each of these branches, count how many are there, and we can reconstruct their population history like this. So right now, today, generation 5, there are 16 men alive. So we can plot this. Down here is generation 1, 2, 3, 4, 5, and there's 16 men that are alive. So let's now move backwards to generation 4, the previous generation. Well, there's 2, 4, 6, 8 branches here. We can plot that at generation 4. And then move back one more generation, generation 3, 2, 4 branches. We can plot that. Back one more generation, generation 2, 2 branches, generation 1, 1 branch. And so just looking at the family tree and the number of branches at various stages of history, because this is like a time scale, like a family tree, you can say how many people were alive at a various point in time. So when we did our little time travel, we watched the branches of this family tree grow. We can kind of go back in time. In a sense, the family tree allows us to travel back through time to see at various points in time how many branches were there, how many people were alive. And then when we draw it, we can see that this family has had a history of population growth. This branch is showing an upward curve. This sort of family tree can also record periods of population stasis when there's no growth. So let's say again, we're going to travel back in time, supernatural abilities, and watch a family tree change with time. Let's say there's this male ancestor, he has a son, maybe a bunch of daughters, but only 1 boy. We're only interested in male ancestry. Then we keep traveling through time forward, and this boy grows up, marries, has a bunch of daughters, but only 1 boy. And this family keeps having this pattern of lots of daughters, but 1 boy through time. And eventually, though, we're traveling forward through time. This boy grows up, marries, and he has 2 boys, maybe some of the daughters too. And then his boys grow up, and they have 2 boys as well, and growth resumes. Well, if we've lost our supernatural abilities, we're back in reality, and we don't know this history, and we look at these 2, 4, 6, these 16 men alive today, we get their DNA, reconstruct a family tree, it looks like this. We can then say, aha, I think I know what happened through history. We can count the number of branches at each stage and draw a graph. So there's 16 guys alive today. This is generation 9. Draw that on our graph. Move back a generation, generation 8. There's 2, 4, 6, 8. 8 branches on the family tree. 8 men would have been alive then. Move back another generation, generation 7, there's 4. Draw that. Generation 6, there's 2. Generation 5, there's 1. And it stays at 1. And we draw a flat line here. So just drawing the number of branches from this family tree allows us to reconstruct what we would only known if we had supernatural abilities. There was no growth for a while, and then the curve goes up. So I'm going through these steps because I want our viewers to see this is how the process works, and we're going to take it one step further now to think about perhaps the most remarkable fact, the saddest fact about Native American history, the dramatic population decline after Columbus arrived. So we discussed in the previous episode that there were ballpark 53 million people here. There's big uncertainty, but there's a lot of people here, many more than we used to think about. And 3 centuries, 4 centuries later, that had undergone a massive collapse, die off due to disease, enslavement, battle, so forth. And those are 10 million people or less here in 1800. Well, how could you detect that with family trees reconstructed from the DNA of living people? Well, let's think about a scenario again. Let's think about time travel. Let's go back in time, pretend we have supernatural abilities again, and we're going to watch what happens, but we're going to include some sort of population die-off as part of our scenario. So we go back in time, there's a male ancestor, he has 2 boys, and we then move forward in time. Those 2 boys have 2 sons, their boys grow up and have 2 sons, we keep going forward in time, this population growth happens. But now at this point in history, half of the boys die off, maybe due to disease, maybe they go off to war, boom, they're gone. And now we keep watching history go forward. Those survivors each have 1 boy. And now we're in the present, and now let's pretend we haven't been able to witness any of that history. If we had, this is what in white the population curve would have looked like. If we were watching and supernatural recording through time, we'd have seen the population grow, and then a whole bunch of people die off so that there's only about 8 people alive then today. And but our question is, and our scenario today is, all we have is living Native Americans. And we can get DNA from these living Native Americans, we can reconstruct their family tree. What should we be seeing if there's been this massive population die-off? Well, think back to a theoretical scenario. I'm going to highlight in blue the family tree that would result if we take DNA from living people. We would not have any access to these people, these branches of the men who died off. They don't leave descendants. We don't have their DNA. All we can see with the DNA from these living people is what's highlighted in blue. So if you then count the number of branches today, we see 8. So we put that in blue on our graph. We're going to compare it to what we would have seen if we were supernatural abilities and watching it in real time. Then we go back a generation. That's generation 6. Go back to generation 5. Well, all we see is the blue branches. We have no access to those white ones that have the red X's because they died. They don't leave descendants. We don't see their DNA. So we still have 8 branches. That's all we see. And you go back in time, here, still 8 branches. And then you go back another generation, you start to see a match between the white curve and the blue curve. You might notice here that the white curve, which is partially obscured now by the blue, goes up and then down. We don't have DNA from these people, just from the survivors, so we have no access when we reconstruct DNA from this DNA-based family tree. We don't see that peak. All we see is this flatlining. So if you've heard the term flatlining in a medical context, heartbeat stops, someone's dead, it sort of has a double meaning here that's useful. This smoking gun of a population collapse is flatlining. You can see here, if we were to graph out how the Native American population would have looked perhaps before Columbus, it would have peaked and then gone down. If we try to capture that history, and if we say, what should we be looking for if we have living people today, we get their DNA and we try to recreate a family tree, we should be looking for flatlining. Let me take this example one step further. This was about a 50% population collapse. I mentioned that there was probably more like an 80 to 90% population collapse, from 53 million people down to less than 10 million. So let's change this little scenario and wipe out 80%, 90% of the people that are here. And then the next generation, they only these 2 guys down here reproduce. So if we were watching this in real time, we'd see this population grow and then boom, a whole bunch die off, and there's only 2 left in the next generation. Well, in blue, once again, is the family tree we could, so to speak, see if we took DNA from these 2 living survivors. We'd only have access to these branches. And this is how the graph then would look if we reconstructed their history. So we start in the present. We've got these 2 men who are alive. How many branches are there? 2. Generation 6, there's 2 branches. Then you go back a generation. We can't see any of these guys who were on the tree but died because they don't leave any descendants. Even this branch down here, gone, gone, gone. All we see is still 2 branches. You go back a generation. Even though this blue extends up here, it only connects to dead people. So all we see here is this here and this right here. There's still 2 branches. You go back a generation, still 2 branches. Go back a generation. Yes, we can see there's an extension up here, but all this people, this whole half of the tree, gone, dead. We can't see them. So all you see is 1 branch. You go back a generation, 1 branch. My point in going through these scenarios is that when there's a massive population die-off, there is a long period of flatlining. I said in generation 5 is when the actual event occurs. A whole bunch of people die off. But notice that the flatlining extends far back beyond generation 5. Because you killed off so many people, you lose large chunks of the family tree, and it's just empty. Those people who should have been there, gone. They haven't left descendants. So it's this long flatlining that should be the smoking gun. Now, I've basically just taught you all advanced population genetics, which is a complex field. I don't expect everyone to follow this the first time. You can go back and watch it again. The bottom line of what I'm saying is if we're going to take DNA from living people and we're looking for the real history of what's happened after Columbus, we're looking for flatlining in the branches of the family tree. And I'm going to add one more little caveat here. After there was a population die-off, some of these populations recovered. So in this column right here, we're based on the 2010 US Census of various tribal groups from the most populous to the down to those who have fewer, and it goes down further. I'm just taking the most populous groups. Navajos have nearly 300,000 people in 2010. The Sioux had 112,000, and so forth. For some of these groups, we have historical data. So we know that from history, in 1868, there were only 9,000 Navajos. So they've increased over 30-fold in just over a century. The Sioux were at about 25,000 people in 1890. They've increased less dramatically. The Pueblos are also around 9,000, this time in 1861. They've increased less than the Navajos. The point is, after this population went down, down, down for several centuries, some of these groups have now recovered. So if we want to know what the native population family tree should look like, it should be a long period of flatlining, predating Columbus because the collapse was so big, and then a recovery. So adding those branches there, and we're going to add a little bit of recovery here at the end of our graph. So long story short, even if you didn't follow everything I said, this is what we should be seeing in the family tree of Native Americans, given what we know about what happened after Columbus arrived. So this purple line here is 1492. Down here you have 1200 AD, 1300, 1400, Columbus arrives, 1500, 1600, 1700, all the way down to the present. What we should see is a flat line. A whole bunch of the branches in today's Native Americans are now gone because their relatives, their ancestors died. Their relatives, their ancestral relatives. And because it was such a massive die-off, we're going to see flatlining that precedes the arrival of Columbus. So if we look at this particular section of the family tree, and if you're looking carefully what's happening here and recognize this is a timeline, there's a lot of long branches, not people. It doesn't look like this staircase step. There's a lot of flat lines, no one else branching off. What does that mean? It seems like this might be the smoking gun of their population decline. Well, the mainstream community, this is the paper from which the primary data we're taking, they tried to reconstruct population histories for various peoples, and they say, yes, we can detect the decline. They do not detect the recovery after the 1800s, 1900s. So the mainstream scientific community can only detect part of this history. And I'm arguing that the reason they miss the recovery is because they have the wrong time scale. Our family tree, based on the Y chromosome clock, is much shorter, shallower than we think. And if that's true, we should be able to see the real history of a long period of flatlining because of the decline and then recovery in the 1800s. Well, if you're looking at this tree, there are a lot of empty branches here, and then some sort of a stair-step pattern closer to the present. Well, this is what we should be seeing, given what we know about what happened after Columbus arrived. I've got two lines here because there's always some sort of uncertainty. This is biological data. So some groups started recovering in the 1800s, some more like 1900. 1890, again, the Navajos are at 9,000 people. That's close to 1900. Well, if you reconstruct the history, and this is a complex process, I've written a technical paper where you can read the details. The blue lines represent what we can recover from that history. Not only is there a long period of flatlining, but there's also a recovery. And this is very close to what we see. So this, let me stop for a moment. The fact that I can take the family tree of Native Americans and reconstruct their population history, and I see a long period of flatlining that predates Columbus because there was this massive die-off, and then I see recovery. This is the only data set. This is the only time scale that captures what we know, creationists and evolutionists, after Columbus arrived. This is a remarkable, strong smoking gun of the veracity of the young Earth timescale. You can't see this evolution. You only see this with young Earth creation. And I'd say the only reason you can see this is because the young Earth creation timescale is true. So you see the flatlining. I said there's been recovery in some of these groups. You can see the recovery there as well. Now, I've deliberately hidden pre-1200 because pre-1200 is where it gets really shocking. I've taken this long period of our episode to describe why the post-Columbian history is true, because number one, it has huge apologetic implications. We're seeing real history that evolutionists cannot, and we see it because we have the timescale right. And because we have the timescale right, have captured history after Columbus, now what I'm about to show you is all the more believable. It's explosive, but it's believable. I'm going to show you two graphs of how this graph looks if we go to pre-1200 AD. Two graphs because we still can't be very precise about where Noah is. I'm going to show you my best guess about where Noah is, and then I'm going to show you another possibility of where Noah is, and somewhere in between is probably where the answer is. So if Noah is where I think he is, and that sets the boundaries for the whole tree and allows us to be exact about our dates for the other parts of the tree, the Native American part of the tree, that branch where we saw all those gray branches as Native Americans come off and leave Central Asia, that branching and moving over from Central Asia happens in the 600s to 800s AD. This line begins right here. They undergo rapid population growth around the 800s or 1000s AD, and then of course flatlining sets in because so many of their descendants died off. You have this flatlining that occurs, and then there's a recovery. What this means is today's Native Americans are descendants of people who came over in the recent, so to speak, AD era. If Noah is somewhere else, it bumps that back to maybe 250 AD, somewhere between 250 and 500. Again, there's two lines because that's part of the statistical uncertainty here. They came over around that time, underwent massive population growth between 500 and 700 AD, and then, of course, there's a collapse. Whether it's there or there, it doesn't matter. The big point is this. Looking at archaeology, the earliest archaeology for civilization in the Americas is the Olmecs, and that's dated to pre-1000 BC. And I can say that even from a young Earth perspective, it goes back to the earliest BC times. Yet what I'm saying, based on genetics, the people who are alive today came from groups who came over after that fact, sometime in the AD era. What that means is the people we see today replaced whoever was here first. I don't know if they killed them off, if they brought with disease. See, there's some of the questions we're going to raise in subsequent episodes. This is, and if you wanted to read more of the technical details, this is a paper that just came out. We published in the Answers Research Journal. You can find it on our website. But let me stop here and summarize these explosive findings in short order. Native Americans today, Sioux, Navajo, Latin American tribes and nations, these people are not the first Americans. They are descendants of Central Asians. So evolutionists don't dispute the Central Asian connection. They dispute the timescale. I'm saying the timescale is what changes all this. They arrived in the AD era, and because there's archaeological evidence that long precedes that, they must have replaced whoever was here first. And this raises all sorts of questions. I'll just list a few here. First of all, why did people leave Central Asia? What was going on in Central Asia in 250 AD or 600 AD that would push people across the Bering Strait and come over? What happened after they got here? Apparently, they wiped out whoever was here. Did they bring disease like Europeans brought? Were there some massive battles that happened? And of course, the biggest question is, who were the first Americans? Who were these people who were here first? Who did they come from? What were they doing? This explosive discovery creates a dramatically new research paradigm, a dramatically new paradigm for understanding the history of the Americas before Columbus. And this is just the beginning. This is the new history of the human race. We've seen now the evidence for the resettling of the Americas before Columbus. And this also is just the beginning of now rewriting what we understand happened when these people came and what happened before these people arrived.
Well, you know, Dr. Jeanson, secularists out there think creationists are radical anyway because we stand for God's word in Genesis and stand against evolutionary ideas. So I guess you're going to be considered radical for your approach to history here.
They're going to accuse us of all sorts of things, and yeah, it's what else is new? They accused us of these sorts of things long before we made such comments about the Americas. But that's part of the reason I wanted to emphasize the post-Columbian history, because it's so radical and so likely politically incorrect. Why would anyone ever say this? Well, because we're the only people who can capture the known history. We're the only people who can capture the collapse and the recovery. So if you want to know what happened, if you're a Native American, you want to know what happened here, we're the only people who can tell you and can reflect what we already know happened post-Columbus. And so that's why I think it's this model that should be trusted for what happened before Columbus. That's to me the key scientific link. So it's not just we're destroying what everyone held dearly. No, we're the only people who can tell you and show you the echo of what we know happened after Columbus. And so therefore we can go back and revisit what happened before Columbus.
Sort of reminds me when secularists, evolutionists who reject God's word look at the fossil record and they say there's no evidence of a flood because this took millions of years. But of course, if there's no millions of years, you realize that had to happen in a very short time. It all makes sense. with a catastrophic flood. And you're looking at this in regard to human population. And of course, the Bible's timeline would tell us it's much shorter than what we've been told by the secular world. Of course, the Bible's timeline is right, and it explains what you're seeing in genetics. So what can we look forward to in episodes 13 and 14 coming up?
We're going to begin to try to answer some of these questions that have just been raised by these findings. So in episode 13, we want to look at a neglected history of the pre-Columbian Americas. There's been evidence lying right in front of us that we've been missing that begins to give us some clues as to what these people were doing. And in fact, is consistent with the genetics and anticipated the genetics that I just showed. That's episode 13. Episode 14, we want to look at the question of what happened to the Maya. So there's a ancient pre-Columbian civilization, fairly glorious one in terms of what they were able to produce, not necessarily glorious in their cultural practices. But even Wikipedia says that the collapse of the Mayas, the disappearance of this Mayan civilization, is one of the great unsolved mysteries of archaeology. And the genetic discoveries we've just looked at might offer some clues and help us retell and solve this long-standing unsolved mystery. There's as many solutions to this mystery in the mainstream community as the mainstream community has for what happened to the dinosaurs, just to give our viewers some sense of how much of a nagging problem this has been. Well, with genetics in hand, we now have some new tools by which to say, I think we've got some answers, and they're really remarkable.
Well, that's something to look forward to for the future episodes. And if people want to see all the past episodes, now, Answers.tv, it's our own streaming service. Answers in Genesis now has its own streaming service, just like Netflix does and Disney Plus and so on. But we would encourage you to subscribe to Answers.tv, just over $3 a month for a year's subscription. That's very, very inexpensive. And all these sessions will be archived on there. But you can also go to YouTube, the Answers in Genesis channel, and they'll be there as well. Well, with that, we look forward to the next 2 episodes next week. So thank you, Dr. Jeanson, and we'll have you back here when we go through that new information that you have that's going to give some very interesting answers to all of this.
Thank you.